Jones here. We wanted to make a video for you guys so that way I go through every single problem. Maybe you have a question about something that was on here and you may have missed it. So this video just goes through each problem to help you with it. So I'm going to pretend like I'm taking this test as it is, just so that way I don't just show you the answers. So let me just type in all my stuff here, and this stuff we're good with. So question 4 is when it starts getting into the math, and then I'm going to show my work over here on a Jamboard to the left. So hopefully my handwriting is a little good to see. But so this says rewrite 4 to the 5th power in expanded form. So that means expanded means just like stretched out. So that base is 4. And then the exponent tells us how many times that 4 is being multiplied. So there's 1, 2, 3, 4, and it's to the 5th power, so there should be 5. So this is how we would expand it out. So my answer would be this one. There's 4's being multiplied by 5 different times. Okay, it's not 4 times 5, it's 4 to the 5th power, or 4 is being multiplied 5 times. Okay, next one. Rewrite 3 times 3 times 3 times 3 in exponential form. So it's kind of the opposite of the last question. So what number is being multiplied? That's our base. So the number that's being multiplied is 3. And it's being multiplied by itself 4 different times. So that would make the exponent 4. So we need to look for this as an answer choice. Looks like that is option 4. Okay, so 3 was the number being multiplied. That's the base. It was multiplied 4 times. That's where I got the exponent from. Okay, write 3 squared times 3 to the 5th power as a single power. So it wants you to do this operation. I don't have my notebook pulled up, but if you look in your notebook, there is a certain rule when you're multiplying. And when you're multiplying, you're actually adding the exponents. So the bases would stay the same. And it's really like you're doing 2 plus 5, even though my plus is a little weird there. So I would just add the exponents. So my answer, my base should still be 3, and then that's 3 to the 7th. Looks like it should be option 2. Clear my frame. Okay, so this is kind of the opposite. So it gives us the answer, but it wants to know which one it could be the answer to. So I'm just going to go through and just do each one just to be sure. So I know I'm looking for 5 to the 6, and these are all multiplying problems, so I'm going to add all of the exponents. So the first one, we would add the exponents of 2 and 4. Well, that looks like 5 to the 6, but I'm just going to be completely sure. Option 2, I have 5, and then we're adding the exponents still. Well, 11 plus 5 is 16. Well, that's not it. My next one is 5 thirds, 5 to the 3rd power, and I'd be adding that 2. So it's I'm adding, this would be 5 to the 5th power. I wouldn't multiply those. I'm adding the exponents. And then these don't even have exponents. They have, we would multiply that out and it'd give us 30 if we did, but this isn't close to what we're looking for. So it looks like this first option here, a little squiggly, that was the correct answer for that one. So it should be the first one since I'm adding those exponents. Okay, so this we have our division rule, and when we're dividing, we actually subtract the exponents. So let me just write this over here. So I keep the base the same, and then I'm subtracting the exponents. So this is really like 5 minus 3, and then that should give me 4 squared. Is that an option? Yeah. And see, it tries to trick you because we just did adding, and that's an 8. And there's multiplying, so just be real careful. We have to subtract here. Should be option 3. Okay. Then, same thing here. So it's still division. It has that fraction line. And then we would subtract our exponents. Well, if we subtract 7 and 3, we keep the base, but the new exponent should be 4. So that looks like that would be option 1. So remember, if we're multiplying, we would be adding the exponents. If we're dividing, we'd be subtracting the exponents. Okay, got another subtraction one. So this wants us to know how we would solve it. It is a division problem, so we know we will be subtracting those exponents. This is not looking for the answer. So we just need it to show where we're subtracting the exponents. Well, this looks like subtracting. Just to be sure, though, I'm going to look at all of them. This is adding. That's a dumb choice. This is multiplying. That's a dumb choice. This looks kind of the same, but this is division. This is the only one. Only one. So, yes, this may look similar, but if you look, it's like that is the whole exponent. That doesn't make sense to us right now. So just subtracting. So it would be option 1. Okay, this wants to know how we would solve this one. We have these little dots, and that means that we are multiplying. When we multiply a problem, we add the exponents. So this one we're subtracting. That's dumb choice. This we are multiplying. We're multiplying in the problem, but we're not doing that to the exponent, so that's not right. This one we're adding the exponent, so that one looks good. And then this one, I'm not really sure what it's doing there. So we are adding the exponents with this one, so it would be option 3. Remember, division, we're subtracting the exponents. When you multiply, you're adding. Okay? It's kind of like they go hand in hand. Okay, this is my favorite rule, and I think a lot of us struggle with this one sometimes. I think you get 2 in your head. Anything to the power of 0 is 1. Always. Doesn't matter how crazy it looks, it's always 1. Not 0, 1. Okay? So that means this, we don't even have to look at it, really. We see that 0 is an exponent. My answer is 1. We have some crazy stuff in here, but look, everything is being raised to the power of 0. Guess what? 1. Okay? My favorite rule. Then we have a negative exponent here. So this is yet another one of our rules that we have. So we don't like negative exponents. We want to make them look positive. And to do that, we have to find the reciprocal of this. So right now, it looks like x to the negative 6. And if I were to put a number to make this look like a fraction, there would be a 1 under it. Well, I need to find the reciprocal of that, or I need to basically like flip it. So if I do that, I would change to where the 1's on top. And when I flip this, I have to change this negative 6 to a positive 6. So my answer should look like this. So this just has x. Negative 6, no. This has the fraction that I need. And this just changed the sign. I can't just change the sign. I have to do the reciprocal. So it looks like option 3. And all of these rules are in your all's notebook too, guys. Every single one of them. Okay. So we got a few things going on here. So I'm going to rewrite my problem over here. And my handwriting may not be as neat, just since I'm writing on my screen. I'm going to try to make it a little on the neat side. Okay, so I got a lot of stuff going on here, but I'm just going to break it down step by step. So it looks like when I first see this, I see a division problem, but I can't divide anything yet because I got all this stuff on top. So I'm going to do the next step under it. I've got to multiply these first. And when I'm multiplying, I add the exponents. So I'm going to be adding 4 and 6. And then that would be over m to the 8. Okay, well, when I add 4 and 6, I should get m to the 10th power over m to the 8. Well, now it's just division, and now I can subtract those exponents. So if I subtract 10 and 8, and I'm running out of room on my little whiteboard thing, but if I subtract those two, I should get 2 as my new exponent. So I'm just going to write it here. So m squared should be my answer. This says m to the 8th. That's not right. This is m squared or m to the 2nd power. This looks good, but just checking. This is m to the 18th. And this has 1 over m squared. It would be option 2. Because follow all those steps. Okay. So do this first. Get rid of the multiplication. Figure it out. And then do the division. Okay, next problem. So it wants me, it's dealing with some scientific notation. It wants me to write this in expanded form, or the standard form where I write it out to make it look like an actual number. So I have 1 times 10 to the negative 6. And I have to always draw this out. I am going to leave this up here where I rewrote it, and then I'm just going to put a 1 here. And my decimal would be right after the 1 since it's a whole number. Okay, so this is a negative 6, which means I've got to move my decimal to the left 6 times. So if I do that, here's 1, 2, 3, 4, 5, 6. So this would be where my new decimal is. And I know that's hard to see. And then I just fill in the rest of the places with zeros. So 1, 2, 3, 4, 5. So I'm going to rewrite this so it looks a little neater. My answer should look like this. Should look like this. If you wanted to stick a 0 in front of that, just to show that it's 0 for the whole number, that's fine. I think that this should have took either way. So that is it expanded out. That's the actual number. It's really tiny, and that's kind of why we use scientific notation anyways. Okay, same thing here. So this time I want to write this in expanded form. So let me just rewrite it over here. Okay, and again, I'm just gonna put my 4.3 here so I can move my decimal. It's a positive 8 this time. When the exponent's positive on scientific notation, we go to the right. So if I have enough room here, I'm going to move this 8 times. 2, 3, 4, 5, 6, 7, 8. And you may not have to do this, but it keeps my, makes more sense to me sometimes. And then I fill in these little spaces with zeros. And I'm going to make mine look a little neater just because the zeros are all over the place. So I had 7 zeros. So that's 3, 4, 5, 6, 7. So I'm going to put my commas here so that way I can read the number a little bit better. So that looks like 430 million. Hopefully I said that right. This should take it with commas and without. So if you didn't put commas in, you should be good. That's how I got that. So if it's a negative exponent here, we move the decimal to the left. It's a positive exponent here, so I move it to the right. Okay. Next question. What is 0.00000057 in scientific notation? So this is kind of the other way of thinking of it. So we have the expanded form or the standard notation already, and we've got to put into scientific notation. So the first number in scientific notation has to be between 1 and 10. So I've got to move the decimal here to where it's between 1 and 10. So I'm going to write this number here. I have 5 zeros. You guys are probably seeing my thinking face while I'm writing this because I'm trying to concentrate. I need to make this look like between 1 and 10. So I'm going to move my decimal over to when it looks between 1 and 10. And I'm going to try to match this as good between the zeros as I can. So I moved it this many times, and now it should be 0.57. That's not between 1 and 7, so I have to move it one more time. So my decimal now should be between the 5 and the 7. I couldn't go another time because then it'd be 57, and that's a lot bigger than 10. So 5.7 is the first part. And I just want to look. I just want to look and see at my answer choices. Well, that's not right. The 57 isn't right, so I know it's either option 2 or option 3. So let's do our second part then. So we know it's either going to be a positive 6 or negative 6 here. So it's always going to be times 10. And then this is how I look at it from this angle. Maybe Miss Bowman or Miss Druin or Mr. Smith, someone's told you something a little bit different, and if that makes more sense to you, by all means, use it. Okay? But I see this first number being smaller than 1, right? And whenever it's smaller than 1 and I had to move it over to the right, my exponent is always going to be negative. So I always think if it's less than 1, it's negative. But if that doesn't make sense, please don't let me confuse you there. But I moved this to the right. It's a small number, so it's going to have a negative exponent. And then I moved it 1, 2, 3, 4, 5, 6. So negative 6 should be my exponent. And let's say that that doesn't make sense to you. If you're not sure when it comes test time to get to this, you can actually take your answer and go backwards to like see if it's the same as what the question stated. So I know that it's 5.7. And then I've got to move it to the left 6. So 1, 2, 3, 4, 5, 6. So my answer should look like this. And if you look, this and this are the same. So if this ever does get confusing, double check your answer. But this should be option 3. Okay. So Another huge number, got to make it look into scientific notation. So this one might take me a second to write. What is that, 67 billion? Two. Okay, so this one, I know my zeros look kind of weird. This is a whole number, so my decimal is actually all the way on the end there. So I need to move my decimal to the left to make the first number between 1 and 10. So if I do that, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had to move it 10 times to get it between the 6 and the 7. If I went right after the 7, it'd be 67. That's not between 1 and 10. If I went another one, that's 0.67, and that's too small. Has to be between 1 and 10. So, and I always know that it's times 10 to the something. So looking at our answer choices, looks like so far that's the only silly choice is option 2. Don't pick that one. It's 67. That's not between 1 and 10. So same went with last time. This is a really big number. It's bigger than 1. If it's bigger than 1, I have a positive exponent. And I said I moved this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So this should be to the 10th power. And again, I just want to show you just so that way, like, let's say that doesn't make sense. Take this and try to make it look like that. So I know I have 6.7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I fill in all these with zeros. Sorry, some of these zeros look a little weird. And if this looks just like that, you did it perfect. Okay. Without the commas, it may look a little weird, so I'm going to try to add the commas. But it should match up. I think I put my commas actually in the wrong spot. But it does match up. So my comma's a little bit bigger. Yeah, so 67 billion, I think. But option 3 would be the right answer. So let me clear my frame. Takes a second. Okay, so we have to see, I'm gonna move myself over a little bit. We need to see which one this would most likely be associated with. So if you look at your answer choices, they're very different. So the Earth is huge. Bowling balls, like, you know what the size of a bowling ball is. Ping pong ball is really tiny, but a dust particle is like extremely tiny. So you may be able to look at this and be able to tell which one it would be, but I want to write this out in like expanded form or standard notation so that way like I can actually see what number it is. So I have 7.53 times 10 to the negative 12. I know that it's a negative exponent, so it's going to be really, I'm going to move the decimal to the left. So 1, 2, 3, 4, 5, 6. So if I were to write this out, and I'm just going to go ahead and do it here. This would be my number. It's not in scientific notation. That is extremely small. So this would not be the size of the Earth. This would not be the size of a bowling ball. This would not even be the size of a ping pong ball. This would be the dust particle. It's super, super tiny. Okay. Next question. It wants to know what the square root of 81 is. So you need to know what number times itself would be 81. If you had a calculator, you could put it in Desmos like this and it would give you the answer. But I'm just going to write these out. I know that I have 9, so 9 times 9, well, that's 81. But just to be sure, then I would try 8 times 8 to see. Well, 8 times 8 is 64. 6 times 6 is 36. And then 81 times 81, I don't know off the top of my head. I'll check it on my phone really quick, but that's obviously going to be a lot bigger than 81. Yeah, that gives me 65, 61. So my first one was my answer choice here. I just want 9. I don't want 9 squared. That is the square root is 9. Which of these numbers is not a perfect square? So really helps you again if you know your perfect squares from 1 to 15, which I just did 81, and 81 was 9 times 9, so that one's a perfect square. 100 is 10 times 10. Sorry, that 10 looks a little weird. Okay, so I know that 9 times 9 is 81, and 10 times 10 is 81, but maybe you're not sure about these two. Well, they don't look that far away from 100, so let's try 11 times 11. I don't know why it's not liking my second number, but if I do 11 times 11 in my calculator, I get 121. So that means 11 squared is 121. So those are 3 of the answer choices. So A, B, and D are perfect squares. It wants to know which one isn't, and 111 is the correct answer there. Okay. Square root of 87, that is not a perfect square, but we just said that 9 squared is 81. I was about to write something that wasn't the right thing to write. I was about to write 18. I flipped it. I know 9 squared is 81. We just said that in the last problem. Well, what's 87 really close to? Okay, so my next perfect square is 10 squared, and that's 100. So what should my answer be here? Is it between 8 and 9? No. Is it between 9 and 10? Yeah. Well, 10 and 11, we said 10 squared is 100. Well, that's a lot smaller than 100. And then it says 87. The square root of 87 is not 87. Okay, so B is the only answer that makes sense. Okay, these got a little tricky at times on this assignment. I had a lot of people asking me questions about this. So when you see a square root with a fraction, you just find the square root of each of them. So I'm just going to split these up. I have the square root of 16, the square root of 25. Well, the square root of 16 is 4, because 4 times 4 is 16. Well, the square root of 25 is 5, because 5 times 5 is 25. So this should be my answer. Okay, so not 16/25, not this, but 4/5. 4/5 is my answer. Okay, irrational. Irrational is a number that can't be written as a fraction. So let's look at all of our answer choices here and let's just see. So the square root of 81, well, we've talked about that quite a bit in this video. That's 9. 9 is a whole number. Whole numbers I can just stick a 1 under. That's a fraction. So this is rational. Okay. 0.2525. So that looks like it's either a repeating decimal or a terminating decimal, which you should have learned in the video. Terminating decimals and repeating are both types of rational numbers. But just to see, let's just put this in a fraction. Okay, so I went to the Desmos just to see, so a quicker way to do it, and I'm going to put 0.2525, put it as a fraction. Well, it writes it as a fraction, so that is rational. So, pi is 3.1415. It goes on forever and ever and ever. Never stops, never repeats itself. This one is a irrational number. -9 can be written as a fraction because I can just stick a 1 under it. So option 3 is the choice here. Clear my frame. Okay. Which statement correctly compares these two? Well, the square root, and I'm just going to put it here, move my thing. The square root of 16 is 4. So I want to know how 4 and 3.3 relate to each other. Well, 4 is bigger than 3.3. So I'm looking for a greater than sign. So this has greater than, but it says equal to. Well, 4 and 3.3 are not the same, so that's not it. They're not equal to each other. This one says they're bigger than, 4 is bigger than 3.3, so this looks like the right answer. But just to check, this one says 4 is smaller than 3. That doesn't make sense. Okay, so last question. It says, your teacher asked you to help her decorate the bulletin board. She knows the area of the bulletin board is 64 square feet. She needs you to measure and cut the board for each side. How long will the border be for one side? How much total border will you need? There are going to be 2 answers for this question, I can already tell. So whenever I get a word problem like this, I always like to draw a picture. That just kind of helps me think about it. So I'm going to draw not a perfect square since I'm just drawing it, but this is my bulletin board. Okay, so my teacher knows that the area of this bulletin board is 64 square feet. Okay, so she wants to know how much of border I'll need for one side, and then how much total border I will need. And I think this really sounds like a notebook problem if I'm not mistaken. But anyways, so all I'm given is that this is a square and that I know the area. Well, if you think about what the area of a square is, it's just one side. I'm going to put B for border. All sides are the same here. So if I multiply one side by itself, or just all together, I'm going to get my area. So I know that B squared is 64. That's what it told me the area was. Well, to find B, I need to do the opposite of squaring. And the opposite of squaring is finding the square root. So B would equal whatever the square root of 64 is. And if you know your perfect squares, B should be 8. So looking at our answer choices here, this says it's 6 feet long for one side. That's a dumb choice. We know that it's 8 feet. This says 8 feet, this says 8 feet, this says 6. So it's either B or C. So let's answer our next question. So I know it's for one side is 8. How much total border will I need? So if you've looked at any of your teacher's bulletin boards, and I don't know if you can see mine back here, but it just goes around the edges is the border. So I don't want to fill up the whole bulletin board of border, but I want to fill each side. So it's going to look like my little squigglies of my bulletin border. So, okay, I just want to put it around the edges. So I would have 8 feet here, I would have 8 feet here, I would have 8 feet here, and I would have 8 feet here. okay? If I'm putting border on something, it's like a fence. It's the perimeter of the square. So I could multiply what size they are by how many sides, and that would give me the answer. Or I could just add all of the sides up. And my 8s are looking weird, and I'm really sorry about that. But either way you decide to do this, you should get 32. So that should help you pick C instead of B. Submit it. I don't know if it's going to let me view my score or not. I'm going to see. Ooh, and we made 100. So hopefully this helps clear some stuff up. Pause, look at what you missed, and then hopefully what I said made sense to you. You all will have a test, and a lot of these questions are very similar. So please make sure you know your exponent rules. Please know stuff about scientific notation, about your perfect squares. Take your time on it. Don't rush through. This is your first big test. So take your time on it, and I promise you, if you know this stuff and you watch this video, you should be good, okay? So I'll go ahead and end this because this is probably a long video as it is. Thank you for making it to the end. Good luck on your first unit test, and I will see you all later. See ya.